so we're just going to go ahead and start. My name is Abby Rogers. I am the marketing coordinator at DriSteem. And Misty, I'm just checking that you're recording already. Got it. All right. My name's Abby. Anyway, there's a questions tab in the left panel on your screen. Please use that to ask any questions you have throughout the presentation. We will answer them throughout it and also after. You will receive a follow-up email containing your PDH certificate, a PDF copy of the presentation, and a survey once the session is done. Please take the survey. We really appreciate your feedback. And a recording of the webinar will be sent out when it becomes available a little bit later today. And on that note, I will pass this on to Misty.
Thank you, Abby. Like Abby said, my name is Misty Hansen. I'm a product manager here at DriSteem. I work with most of our electric resistive humidifiers, our gas humidifiers, and our steam-to-steam humidifier as well. And today, of course, we're going to be talking about our latest electric resistive product, and that is the RTS Humidifier RX series. So as we go through this today, like Abby said, feel free to ask questions in the question box at the side there. Otherwise, I'll try to save some time at the end of the presentation to answer any questions as well. All right, let's get started. All right, so just to start off today, I wanted to go through a quick overview of selecting an isothermal humidifier, how we end up at an electric resistive humidifier to begin with. And then we'll talk a little bit about DriSteam's products that we offer before diving right into the RTS and some of the great features about this product. We'll go through those, and I'll make sure to throw in any comparisons to legacy products. If you guys are familiar with the Vapor Mist or the Vapor Stream, those are two very popular DriSteam electric resistive humidifiers that are currently on the market. So I'll make sure to throw in comparisons to them. So just some of those features. We'll just do a quick overview of the models, talk about universal water, precision steam output, which is very important for some applications. Talk about integrated drain water tempering, and then finish up talking about drain settings. All right, so this is what we use at DriSteam to kind of guide somebody through selecting an isothermal humidifier. So these are going to be humidifiers that boil water and make steam versus humidifiers, adiabatic humidifiers that basically produce a mist, a cool mist. These are going to be the steam humidifiers. So the first place you always can land for saving money is just going straight to boiler steam. If you have a boiler available, you could just purchase a dispersion panel or a steam injection tube, stick it right in the duct, and put that boiler steam into a space. If there's any concern over boiler chemicals getting into a space, we do offer a steam-to-steam humidifier that takes the steam from the boiler, uses that as the energy source to boil clean water, and send that into the space. So if the boiler steam isn't available or it doesn't seem to be a good option to use, the next step is natural gas. And that's just a natural next step because a lot of buildings have natural gas running to them already. And natural gas is less expensive than electricity. So the operating cost of the humidifier will be lower with a gas humidifier. Although natural gas humidifiers are more expensive up front, that's something to consider as well. The other thing with gas humidifiers is the smallest capacity unit sits about 50 pounds an hour. So anything less than that, you're probably going to want to go with an electric resistive humidifier just so you can have the better turn down. Gas humidifiers don't turn down as well as electric humidifiers do. So if boiler steam is not an option and we've chosen to not use gas, that leaves us at electric steam humidifiers. And even there we have options. So there are electric resistive humidifiers that use electric resistive heating elements, where the heating element actually gets hot to boil the water. That's what the RTS humidifier is. And then there's electrode humidifiers. So electrode humidifiers, they use conductivity probes in the water, and they don't actually get hot. These are going to be the units where you have the plastic cylinder that gets replaced. So there are a couple things to consider when you're trying to decide between electric resistive and electrode. Electrode is going to be less expensive up front, but you do have the lifetime cost of replacing that plastic cylinder, as well as the environmental impact of replacing that cylinder and throwing that cylinder away. The electric resistive humidifier is going to be more expensive up front, but you just clean the tank, you don't replace the tank over the lifetime of the humidifier. Another big difference is going to be the accuracy of the humidifier. If you need very precise steam output, you need plus or minus even 3% RH, you're going to want to go with the electric resistive humidifier. The electrode humidifier, it just by design, electrode humidifiers drain randomly. You can't time drains or anything like that. And of course, when you're draining a humidifier, you don't have any steam output, and that is not a place you want to be, especially when the output requirement is 100% and you're draining. So that's why electrode humidifiers are kind of better for comfort applications, where you don't need to maintain an exact relative humidity. So that's how we get to electric resistive humidifiers, and that is, of course, the RTS humidifier. This is just a quick little chart of DriSteem humidifiers. These are going to be all steam humidifiers. The top section there is all of the electric humidifiers that we have available. We do have electrode humidifiers with the canisters that get replaced. That's going to be that top one there, that little guy, and then 4 rows down, the XT series. Those are electrode humidifiers. The rest of the humidifiers in that section are electric resistive humidifiers, and you can see the RTS humidifier is right there at the bottom of that section. That just indicates that it is the highest capacity electric resistive humidifier that we have, as well as the highest capacity electric resistive humidifier on the market. So it's the biggest electric resistive humidifier. It's just a little bigger than our vapor stream humidifier that you see right above it there. And then the other 2 products on this table are our gas humidifier, the GTS LX series, which was launched 3 years ago, and it is the highest efficiency gas humidifier on the market. So it's high efficiency, low NOx, and we have outdoor enclosures for that. It's seismic rated as well. And then the last product on the list is the steam-to-steam humidifier, and that's the one I mentioned that can be used if there's concern over having boiler chemicals put directly into your space. Okay, let's move on from talking about all of the humidifiers to talking just about the RTS humidifier. So this is our latest DriSteem electric resistive humidifier. I mentioned the large capacity range. That was important for us to have the one style of humidifier that covered the whole range, all the way from 6 to 324 pounds an hour. We'll talk about universal water in detail a little bit, but basically we just use one water level control for all water types. So this is different from legacy products where we had the float valve for RO DI units, and then we used conductivity probes for potable water and softened water. Now we're using the conductivity probes for all water types, and that's kind of the concept of universal water. Precision steam output. I mentioned electric resistive humidifiers have very precise steam output, and we'll get into a little more detail on that. But part of that is that next bullet there. The RTS has single stage SSR control as standard. So every single unit has SSR, and that allows for that precise steam output and also turn down to just a couple pounds per hour on every model. So that's why that turn down is so much better on electric resistive units, specifically if they have SSR control. The RTS humidifier does have integrated drain water tempering. So if you're familiar with DriSteem at all, our legacy products do require an external drain water tempering device. The RTS humidifier does have that built in as a standard feature. And then back-end interoperability, super popular. That's built in as well as standard. The RTS has a very large tank with very easy access for maintenance. We'll take a look at that in a couple of slides just to see the inside of that tank. And then the RTS still uses our same trusted vapor logic controller that we use on all of our products. It does have an upgrade with a touchscreen display, but the controller is still the same, and the interoperability is still works the same way. Smart Drain, we'll talk a little bit about what Smart Drain is. That's a DriSteam feature. It kind of goes to the drain rate of the humidifier. And then mini drain as well. And we'll talk about draining. Draining is kind of an important thing with steam humidifiers because, you know, as you boil water away or as steam leaves the tank, the remaining water in the tank just gets more and more concentrated with total dissolved solids and junk that isn't good for the tank. So it's important to be draining that stuff out as we go along. But draining, as I mentioned earlier with the electrode humidifiers, it can be disruptive at times. So I'll talk about that a little bit and how the RTS handles draining. Okay, and then that was Abby's comment. Okay.
There is a question.
Okay. All right. Yeah, so SSR, that stands for solid state relay, is what the SSR is. Okay. Just to talk about a little bit about the models, I mentioned the capacity range and how high the capacities go. This just gives you an example of the different capacity breaks. So there are a lot of different capacity breaks along the way to 324 pounds an hour. And this also shows how the models are laid out. The model name has the capacity in it. So that first one, the RX6-1, is a 6 pound an hour steam humidifier. And then after that last hyphen, that is the number of heater stages that the humidifier has, and that just naturally happens once we reach a certain amount of amps on one stage. We have to add a second stage to spread out that those amps. So that's how we get multiple stages. and that has a lot to do with the size, the physical size of the humidifier as well. And I'll talk about that on the next slide. So this just shows the different capacities in pounds per hour of the different models. And then, of course, the available voltages are listed there on the right. We do sell the RTS humidifier in Europe, so those voltages are available. Lots of options. Okay, and then as far as the size, I mentioned the stages of the humidifier on the previous slide. So any of the smaller units, anything under 75 pounds an hour, single stage models are going to be in a smaller enclosure. And then there's two bigger sizes as well. And anything that is a two-stage humidifier, so anything that ends in a -2 is going to be this medium size here in the middle. And then the large one, of course, is for the 3 and 4 stage models. So there's just the 3 different physical sizes of the unit with all those models. And that last number indicates the size of the humidifier itself, the physical size. So you can see the 3 different sizes here. This is the indoor enclosure option that you can see. There is an option to place the RTS humidifier outdoors. We have an outdoor enclosure for it. It is heated and cooled. And then other options for this indoor unit is the small unit there, the single stage unit. That one only mounts on the wall. And then the 2-stage one in the middle, it has an optional floor stand just to lift it up. Otherwise, it also mounts on the wall. The big unit, it can sit directly on the floor, or it also has a floor stand option to elevate it up off of the floor a little bit. Okay, and so I know it's not super helpful to look at just a giant box. So here are pictures with the covers off of the units. So the unit on the left-hand side is representative of a 2-stage and a 1-stage unit. The layout inside the cabinet is the same with a tank on the left-hand side. The tank fills up that whole left-hand side, and then the controls and valves are on the right-hand side there. So you can see, I mentioned this earlier, that the access to the tank is very easy. That whole panel comes off of the tank, so that whole front panel is removed, and the heaters are attached to that as well. So when you pull off that front panel, the heaters are on there, and then you just have access to the giant open tank. And we'll look at a picture of the tank in a couple of slides here. So then on the larger units, you can see that the layout kind of got changed up a little bit. And the control cabinet actually sits above the humidifier tank. And an important thing to note here is that it kind of looks like there are 2 tanks in the larger sizes, which if there were 2 tanks, there would have to be 2 steam outlets and 2 fill valves, and everything would be doubled. But it is just 1 tank. We just are using 2 different doors on that tank because of the weight. So the tank is a 14 gauge stainless steel tank on all sizes. But that just means that those doors can get pretty heavy once the heaters are on there. And then if there's any scale or anything that got built up in the tank, that's going to make those doors pretty heavy. So we did use 2 doors on that larger unit, but it is just 1 tank. Okay, we will move on and talk about universal water. I mentioned this a little earlier. This is just how we control water level I actually wanted to point out this picture on the lower right-hand side as well. So that's a picture of our gas humidifier, or GTS LX series. You'll see this picture anytime we're talking about something that also applies to the GTS LX humidifier. So you can kind of learn about that gas humidifier as you learn about this electric resistive humidifier. They kind of work using the same logic. So they're a little family, little VaporLogic family together. And so just anytime you see that picture, just know that that information applies to the gas humidifier as well. So the conductivity probes I mentioned, that's how we control water level. The operating water level, where the water is maintained the whole time the humidifier is running, is between that bottom and middle probe. The water level just hangs out there. As the water boils and steam leaves, we add water slowly and just maintain that water level right there. And then the top probe is used as foam detection. It's a safety. If there's foam in the tank, that means that there's not water being added to the tank, because the conductivity probes think that water is in the tank already, but what it's doing is sensing foam. And if the conductivity probes think that there's water in the tank when there isn't, it's not going to let in more water, which means the tank could fill up with foam and you could have an over temperature situation. So to protect that from happening, we do have the foam detection probe. Water isn't physically able to get that high in the tank. So if water is being detected on that top probe, we know it's foam, and we'll drain the tank before the whole tank fills up with foam, and we do have an over temperature situation. When the heaters are firing into an empty tank, that can be a potentially dangerous situation, because they'll just keep getting hotter and hotter and hotter. And we have safeties built in. The bottom probe there that you see, the low probe, that is a low water cutout. So if water were to fall off that bottom probe, indicating that there's no water in the tank, we would cut the power to the heaters as well, so that we know that those heaters aren't firing into the tank with no water in it, because you will have an over temperature situation. And then this is just UL regulated. There's a temperature sensor on the tank. This is for all humidifiers. They require a temperature sensor, and that will cut the power to the heaters as well. We just have this bottom probe that would save the humidifier first before that over temperature switch even had to go off. Okay, so precision steam output. We'll talk a little bit about the options to choose for precision steam output in a few slides more towards the end of the presentation. But one key piece of the precision steam output for the RTS humidifier, and I mentioned this about how the water level is maintained between the middle and bottom probe on those conductivity probes. So we use two fill valves, actually. One is a fast fill valve, so water freely flows through that valve. We use it for drain water tempering, the integrated drain water tempering, and then also to quickly fill the tank. And then we also have a smaller valve. It's called the precision fill valve, and that is what we use to maintain the water level in the tank. So if we were to use that fast fill valve to maintain the water level in the tank, we would be adding too much cold water at once, and we'd be quenching the boil of a humidifier and losing steam output. So it's pretty sensitive. All humidifiers are pretty sensitive. When you add cold fill water, you're going to lose boil and steam output. So this is our solution to that, is to just pulse water in with that precision fill valve a little bit at a time. And we actually have an algorithm that pulses water in at the same rate that steam is leaving. So we're never adding too much water to the tank, and that's how we're able to maintain that consistent water level in the tank. Okay, this slide is about integrated drain water tempering, and I'm not going to walk through every single step, but I do like this slide just for the picture that is in it. So I'm just going to kind of walk through the inside of the tank here a little bit. You can see the gasket around the outside edge there. That tube hanging down on the left-hand side from the top of the tank, that is where we keep the conductivity probes. Keeping it in a well like that keeps boil from affecting the water level control. So inside the tube, the water level is calm versus outside of the tube, the water level is rolling just because of the boil. It's constantly boiling. So it can get pretty rambunctious in the tank. So that's why we have a well for the conductivity probes themselves, so they can accurately determine the water level in the tank. And those probes are removable from the top of the tank. That's how those can be cleaned, or like if the gasket needs to be replaced or something, that's how those do come out, is through the top of the tank. And then on the right-hand side there, you can see there's a tube that goes kind of from the top of the tank to the bottom of the tank. And that's where I mentioned the fast fill valve that we use for drain water tempering. That's where that fast fill valve comes in, is right there at the top. And then that water is directed directly down. If you look very closely, you can see the drain port is right there at the bottom of that tube. And that tube kind of acts twofold. So it's used for drain water tempering, getting that cold water right at the spot where it's needed the most, right there at the drain. And then it's also used to keep scale away from the drain port to reduce any chance of the drain clogging up. And then it's a full port drain valve as well. So if anything were to get in there, it's likely that it would just get washed away. But it's actually pretty neat when you look inside of one of these tanks after it's gotten scaled up. It kind of looks like a mini bomb went off right there at the drain port, because all the scale's blown away from that corner of the tank right there. So that works very well for keeping scale away from that corner of the tank. And then one last feature I wanted to point out on the tank is that the tank is sloped away from the front of the tank and then away from the back of the tank. So the slope, the bottom of the slope actually lines up with that tube and with the drain port. And this is to get all of the standing water out of the tank. So at the end of the season, there isn't just water sitting in the tank, getting stagnant in the tank. We try to get rid of all that water. The other thing that this slanted tank helps with is just keeping water away from the front edge when you remove that front panel. Okay, and then like I said, I'm not going to walk through the whole drain water tempering process, but you will get the presentation afterwards if you're super curious. So we'll jump into draining. I mentioned draining and how humidifiers have to drain. So with the RTS humidifier, we have this feature called Smart Drain, and it uses the conductivity probes that we were talking about. And what it does is when the humidifier gets to the install site and is first turned on, the conductivity probes will read the conductivity of the water and automatically determine a drain rate based on the water conductivity. So the user doesn't have to enter their water conductivity. They don't have to enter other information to tell the humidifier when to drain. It will automatically do that on startup. And so Smart Drain picks the drain rate that DriSteem recommends for that water conductivity. If your water changes over time, say if you switched the humidifier to running on RODI water, or the water changed naturally over time, the conductivity probes would read that and adjust as necessary. So it will change the drain rate if the water changes in the humidifier tank over time. And then the RTS, of course, it ships with Smart Drain enabled, trying to make it as easy on the customer as possible. They don't have to know a bunch of information to get their humidifier to drain appropriately. So then Smart Drain is going to work for most people. Smart Drain is schedulable. So with DriSteem, you can schedule your drains. The humidifier will ship from DriSteem scheduled to drain at midnight. So even if the Smart Drain target is reached and the humidifier says, I need to drain now, it won't drain unless it's midnight. So it will wait until midnight to do a drain. And that's just so that you don't have those unexpected drains. I mentioned that with electrode units. You can't schedule drains on electrode units. They're just going to drain randomly whenever they have to maintain that conductivity in the water. So with the electric resistive humidifier, with RTS, you can schedule the drain, and it will only drain at midnight, standard out of the factory. That is user adjustable, the time that can be set. The only time it would drain outside of that would be if the humidifier detected foam. It's not going to wait until 12 a.m. to do a foam drain because that is a safety feature. So that can be scheduled to drain at any time in a 24-hour period, and then you can select the number of days in a week that you want that to happen. So it's pretty flexible as far as that's concerned. If the user seems to be having a problem with Smart Drain, they can switch over to User Drain. And User Drain is just where the user determines their own drain rate. So their own, the way we set drain rates is on cycles of concentration. So it's a target. After the tank gets so concentrated, then it will perform a drain. So they can increase that number or decrease that number based on what Smart Drain has set for them. If they need the humidifier to drain more often, they can lower that number. If they need the humidifier to drain less often, they can increase that number. The only thing to be wary about when increasing time between drains is that the concentration of minerals and things like chlorides are going to be building up in the tank if you're not allowing it to drain. Okay, so then kind of that's talking about Smart Drain versus full drain. Those are kind of, how often the humidifier drains. And, 99% of the time, Smart Drain is going to work just fine. Like I mentioned, it will only drain at midnight. So if the customer needs 24/7 output or something like that, then they would go to user drain. It's just user drain is just a nice feature to have in case smart drain isn't working for somebody. So then we'll talk about doing full drains versus mini drains. So full drains is kind of what it's kind of what DriSteem has done in the past, how our legacy products work. When it's time to drain, the whole tank will drain and start over. So the problem that can happen with full drains is the downtime of the humidifier. So sometimes, depending on the tank size and the fill rate and the drain rate of the humidifier, it could take maximum about an hour to do this whole cycle where it does a tempered drain, does a flush, it flushes out the lines in the tank, it opens the fill valve and the drain valve and kind of cleans that out. And then it fills back up and starts boiling again. That could take up to an hour, depending on the model of the humidifier. So that's why it's important to have those drains scheduled, because you don't want that happening in the middle of when you need steam. So that's how full drains work. If a customer does require 24/7 output, they can't withstand any downtime to have a drain. There are customers who require this. Then they can switch to a new option on the RTS, which is called mini drain. And full drain is what is standard on the RTS, so that's what would ship standard. Although prior to when the humidifier is selected in our sizing and selection software, mini drain can be chosen. And what mini drain is instead of doing full tank drains and draining the whole tank at once, we just drain out little bits of the tank at a time. About 20% of the water leaves. We leave the heaters on in the tank, so we don't lose any steam output when we're doing a mini drain. And this is how someone could maintain 24/7 steam output, because we are draining out the concentrated minerals in the tank, but we're able to maintain the steam output while we're doing that, maintain the water level. And of course, our precision fill valve is kind of the key behind that, where we're adding water so slowly that it doesn't make a difference to the steam output. And then there is a downside to mini drain. There can be accelerated wear on the drain valve. As you can see on the slide, it could be doing a mini drain from anywhere between 15 minutes to several hours. So that's just a lot more wear on the drain valve than, say, doing a one full drain once a day or 3 times a week, or whatever it is that you have it scheduled at. And then another downside of mini drain is that the integral drain water tempering doesn't work with mini drain. So an external tempering device would need to be used if mini drain was being used. And this is an option in VaporLogic to just go in and switch it back and forth between full drains and mini drains, user drain and smart drain. It's all on the touchscreen display. The user can just go in and change that information themselves. There is a warning that comes up when you switch to mini drain, just saying that the integrated tempering is going to be disabled, and you just have to approve that. So we don't just disregard that. Okay, so we talked a little bit about precision steam output with maintaining the water level and using the 2 fill valves. But this is kind of talking more about just in general. You'll want to use RO or DI water just because that significantly reduces the chance of foam drains. And a lot of times, if people have had problem with foam in the past, they're going to have problem with foam in the future. It's just one of those things where it's the perfect makeup of the water, and that's where that foam ends up coming from. And if it gets too concentrated, if those minerals get too concentrated, in some areas, that's just what happens. So, of course, RO/DI water will significantly reduce that chance, as well as reduce the amount of maintenance required to the humidifier as far as tank cleaning goes. You, of course, have to maintain your DI beds and RO membranes in order for that to work out well for you. But the mini drain option will actually help with foaming as well. If that were to ever be an issue, switching over to mini drain versus switching over to RO/DI water could very well resolve that problem for you because you're draining more often. You're draining out those minerals and those concentrated minerals more often. And then, of course, electric resistive units are going to provide the best controllability. And the RX series does have the one-stage control by SSR to provide the plus or minus 1% RH output of the humidifier. So the SSR is really the key there, and that also helps with the turn down to just get down to a couple pounds per hour. You can be very accurate with an electric resistive humidifier. Gas humidifiers are not as accurate. They're not as reactive. The SSR is way more reactive than your blower is going to be on your gas humidifier. So it really is a great humidifier for accurate steam output, maintaining steam output. And then, we throw around the accuracy of the humidifier, but that the accuracy of the RH in the space itself definitely does depend on external factors, such as like unexpected air loss or opening doors and windows. Those can definitely cause temporary excursions in your space relative humidity. Okay, so I pretty much have gotten through everything that I wanted to get through. I'm just gonna do a quick summary and then take any questions that anybody has. So just a quick overview of what we went through today. We have the wide range of models, large capacities, multiple capacities, multiple voltages available. There are many features included as standard, and this is an improvement over previous generations of electric resistive humidifiers from DriSteem. BACnet just being included as standard is a big one. Having that drain water tempering and not needing an external device, even for installing, is going to make installation easier. Universal water, just having those conductivity probes. They have smart drain to automatically determine the drain rate. And you don't need to change anything when you change water type. The humidifier will just figure it out on its own. And then SSR control is a big one for that accurate and responsive steam output and control. And then draining. Draining is a big one. So I just mentioned smart drain. Allowed drain times, very important to alleviate full tank drains when humidification is required. It ships from DriSteem scheduled to drain at midnight, but we don't know if a customer, needs humidification at midnight. They could, and then it could be draining right in the middle of when they need humidification. They can go in and change that to whenever they wouldn't be needing that humidification. And then mini drain for 24/7 output. You can just keep the humidifier running. Okay, so I will move on to if anyone has any questions, and I see we do have a question here. So let's see. The question is about SSR and if it's on each resistive heating element, or each stage, I guess it would be. And actually, so there's only one stage that has an SSR. The other stages do have contactors. But how it works is the SSR is always the modulating stage. So once the SSR is full, is done being used, has maxed out, then it will click on a contactor, and then start modulating 1% at a time on the SSR, so that you can still have that accurate output, because that SSR stage is always modulating. And of course, SSRs, they have a lot longer lifespan than contactors, so you don't have to worry about always using that SSR stage and wearing it out, because they don't have any moving parts or anything like that, like on contactors, and they don't go bad nearly as often. So hopefully that answers your question. Yeah, it's just the one stage is controlled by SSR. It's not 100% SSR, which is something that we offer on our VaporStream humidifier, where every stage is controlled by SSR. All right, and then I just wanted to throw out here that you are able to sign up for DriSteam's sizing and selection software, DriCalc, or just reach out to your rep and they can help you with any additional information that you need regarding that. Okay, are there any other questions that I can answer for you guys today? Otherwise, Abby will be sending out the presentation and the recording a little later today. All right.
Thanks, Misty.
Yeah, thank you everybody for joining us today, and we will talk to you soon.